For this problem, I've chosen these two functions up here. F of x equals x minus 2 and g of x equals 2x plus 3. So what we're going to do is do a few things to them. We'll add them, we'll take the difference of them, we'll multiply them, and we'll take the quotient. So in the first part of the problem, if I add the two functions together, they simplify down to 3x plus 1. Now, 3x plus 1 is a linear function. It's got a y-intercept of 0, 1, and from that point, I'll move up 3 over 1 to apply the rise to 1 ratio of 3. Or I can move down 3, left 1. Either way, I get this nice line. The domain and range are all real numbers. There's no restrictions on an input, there's no restrictions on an output. Over here with the difference, I have to be careful because I have a subtraction of a quantity. So if I am careful with my simplification, I'll get negative 2x minus 3. That also is a linear function. It's got a y-intercept of 0, negative 3, and a slope of negative 2. So I'll go down to right 1 or up to left 1. And in either case, I get a nice negatively tilted line right here. Again, domain and range are all real numbers. For the third part, I'm going to take the product of the two functions. So if I take the time to FOIL these quantities out or use a multiplication grid, whatever you prefer, simplify it down, I get this. Now, this is where you'd want to use Desmos to help you graph. You can see my horrible looking parabola. Yours might look better when you take your pencil to your paper. But on Desmos, it'll tell you that this vertex down here is, I believe, negative 0.25, positive 0.25, comma, negative 6.125. And that tells us the minimum value here. So even though the domain is all real numbers, the range is limited to all values at negative 6.125 and up. Now down here, it asks for any exceptions to what happened here. Anytime you have two linear functions multiplied together, the result is always going to be a quadratic. There's a minor exception to that rule, but we don't have to get into that right now. And then the fourth instance is the quotient of the two functions. If I take x minus 2 divided by 2x plus 3, I'll just leave it alone in that format. And Desmos will show me it's a hyperbola. And it's got two asymptotes. It's got one at x equal negative 3/2, that's this vertical dotted line right here, and one at y equal positive 1/2, that's the horizontal dotted line. And the two branches of the hyperbola glide along those asymptotes, getting ever so close, but never quite touching it. It's kind of weird the way asymptotes work, sort of like an invisible force field. So the domain, sometimes the easiest way to write a domain is write down what x can't be, and the implication is it can be anything except that. Same with the range. So x can't be negative 3/2 in the domain, y can't be positive 1/2 in the range. Here are the asymptotes that we already mentioned. The resulting function, as we mentioned, it's a hyperbola. The official name is a rational function.